Hello there, ladies and gentlemen. This is the first video I'm making on this, and I need you to understand that I have some limited technology, so parts of it will be very, very bad, I can guarantee you, but I'm going to get better at it. This section is 4-4 parallel and perpendicular lines, which is on page 239 in your text. So first we need a couple definitions. So first off, parallel lines. Parallel lines are in the same plane, means a two-dimensional plane. They do not intersect. If the lines are parallel, they do not intersect. And a really key way that you can see this is if they have the same slope. So here's an example of two parallel lines, this line and this line. Those lines are parallel, and actually I should push the arrows there if they're going to be lines. This is another example, this line and this line. These are parallel. They have the same slope. The next one is perpendicular lines. Perpendicular lines are on the same plane. They're still on the same plane. They intersect in one point at a 90-degree angle. And the product of their slopes is -1. So a really good example of perpendicular lines is these axes that we have right here. Our axes are perpendicular lines to begin with. Another example of perpendicular lines, let's say we have this line right here and another one like this. They're going to basically be the axes rotated is what perpendicular lines are going to look like. And I should really put the arrows there. There we go. Now there's only one other way that lines will intersect. If you have two lines in the same plane, they're either going to intersect in no points. They're going to intersect in one point. Now, they can intersect in one point and not be perpendicular. I can show you an example of that. If we have this right here, these two lines intersect in one point, but they are not perpendicular. These two lines here, I'll make blue lines. These lines intersect in one point, but they are not perpendicular. And they don't have to be. They can still intersect in one point. The only other case that we can have with lines, since a line is defined by any 2 points, there's no way that that two lines can intersect in just 2 points, or just 3 points, or just 4 points. The only other way that two lines can intersect is on every single point, an infinite number of points. And that looks like this. These are my axes. This is my first line. And my second line is going to be right over the top of it. Well, it's kind of right over the top of it. I went off, but you get the point. The lines are either going to intersect. If you have two lines in a plane, they will either intersect in no points, like here. They will intersect in one point, like either here, or they will intersect in all points, an infinite number of points, like that. Now I realize I forgot to talk about this on the last slide, so let's talk about it here a little bit. For perpendicular lines, the product of the slopes is -1. We call this the inverse reciprocal. So you remember the reciprocal. If we have a fraction 5/4, the reciprocal is 4/5. So now let's talk about the inverse reciprocal. The inverse is the negative version of a number. It's the opposite of that number. So the inverse of 4/5 is -4/5. So the inverse reciprocal of 5/4 is -4/5. The inverse reciprocal of 2/3 is -3/2. You just flip it and reverse the sign. If it's positive, you make it negative. If it's negative, you make it positive. The inverse reciprocal of -1/8 Boy, I don't know what happened there. Sorry about that. The inverse reciprocal of -1/8 is 8. Now that might make you pause for a second, but first we flip the sign, so we change it from negative to positive. Also remember, the 8 can be written as 8/1. You write any whole number as a fraction by putting it over 1. So 1/8, 8/1, we're just using the reciprocal. So now we come to example number 1. Example number 1 on page 239. We have write an equation in slope-intercept form for the line that passes through -3, 5 and is parallel to the graph of y equals 2x minus 4. So the way that we do this, there's a couple of steps. First thing we have to do is we have to find the slope. Now we know we are looking for Here on this step, we are looking for a parallel line. So parallel lines have the same slope. Well, we're in slope-intercept form here, so it gives us 2x, so m is 2. So m equals 2. Done. Next, we need to use point-slope form to find our slope-intercept form. So remember, our point-slope form looks like y minus y1 equals mx minus x1. I'm hoping this isn't going to be too big for my screen here. So I'm going to go y minus, and my y here is 5, equals m, well my m is 2, times x minus, and my x1 is negative 3. So if I'm subtracting negative 3, I'm actually adding 3. So I've got y minus 5, I just substituted here, equals m is 2, times x minus x1. x1 is negative 3. Okay, so now I need to do some algebra to here. I'll take those little lines away, I think. No, maybe I won't. Okay. So I need to do some algebra here. I've got y minus 5, so I'm going to distribute this 2 through here. I'm going to keep y minus 5 equals 2x plus 6, because I multiply 2 times x and 2 times 3. And now I need to add 5 to both sides to get this negative 5, to get rid of this negative 5 over here. So I've got y equals 2x, adding 5, I get plus 11. This is my answer. Y equals 2x plus 11. I know that is parallel because it has the same slope as my original line here, and I know it passes through the point negative 3, 5 because I use my point slope form. So this is my final answer. This is the line. So now we're going to skip back a couple pages. We're going to go to example number 4. Example number 4 is on page 241. It says, write an equation in slope-intercept form for the line that passes through negative 4, 6, and is perpendicular to the graph of 2x plus 3y equals 12. Alrighty, so we're going to use the very same steps. So the first thing we do is we find the slope. So the slope is, let me see here, I'm going to look at my nice slope-intercept form. Wait a minute! Standard form? I don't have slope-intercept form, those jerks. Well, I got to do some work now to find my slope. So I'm going to write down the equation, 2x plus 3y equals 12, and now I've got to find slope-intercept form. So I'm going to subtract 2x from both sides to get 3y equals negative 2x plus 12. Now I'm going to divide by 3 to get that 3y out of there. 3y divided by 3 is y. Negative 2x divided by 3 is negative 2/3 x. And then 12 divided by 3 is 4. So I've got y equals negative 2/3 x plus 4. So that means my m is negative 2/3. Now I'm looking for perpendicular here. I'm not looking for parallel. So I want the inverse reciprocal. I was going to say proportion for some reason. Don't say proportion. I want the inverse reciprocal. So the inverse reciprocal is 3/2. So that's the slope of the line that I'm going to take. So now I know my slope is going to be 3/2, and my step 2 is to use point slope form to find the slope-intercept form. So I've got y minus y1 equals m times x minus x1. Y minus, well, let's see, my y1 is 6 equals m, my m is 3/2, times x minus, my x1 is negative 4. So since I'm subtracting negative 4, I'm adding 4. So I'm going to keep y minus 6 over here. I'm going to distribute this 3/2. So I've got 3/2 x. When I multiply 3/2 times x, it's 3/2 x. When I multiply 3/2 times 4, I get 12/2, which is 6. Because remember, 3/2, whoops, cancel. 3/2 times 4, or times 4 over 1, equals, well, 3 times 4 is 12. 2 times 1 is 2. 12 over 2 is 6. So that's how I got that 6 there. So now I need to add 6. Now I'm back down here. I need to add 6 to both sides. So y minus 6 plus 6 is just y. I keep my 3/2 x, and then 6 plus 6 is 12. Whoops, 12. And so my answer is y equals 3/2 x plus 12. That is the line. That is the line that passes through negative 4, negative 6, and it's perpendicular to the graph of this line. Now we're still on page 241. We'll call this example 3, but really it's the guided practice problem underneath example 3. I don't really like the way that they show how to do example 3. You can, when you're trying to find out if lines are parallel or perpendicular, you can graph them. That's perfectly fine. But that's not what we've been doing in this section. We've been finding out by the slope. Remember, parallel, if the two lines are parallel, they have the same slope. If they're perpendicular, they have inverse reciprocal slopes. So we want to find out, we want to determine whether the graphs of 6x minus 2y equals negative 2, y equals 3x minus 4, and y equals 4 are parallel or perpendicular, and we want to we want to explain. I keep hitting something with my wrist. I don't know if you can see anything there. So we now know the slope here. We also know the slope on this one, y equals 4. The slope is 0, because there ain't no x. So we need to find out the slope of this one here. So we need to put it in slope-intercept form. So we've got 6x minus 2y equals negative 2. We need to subtract 6x from both sides to get negative 2y equals negative 6 minus 2. Negative 6x minus 2. And now we've got all these negative numbers. I don't care what negative y is. I care what y is. So let's multiply everything by negative 1. So we've got 2y equals 6x plus 2. We multiply the whole thing by negative 1. Now I don't care what 2y is, I care what y is, so I divide by 2. 2y divided by 2 is, it's not 2. 2y divided by 2 is y equals 6x divided by 2 is 3x, and then 2 divided by 2 is 1. So I've got y equals 3x plus 1. So in this example, m equals 3. I also know up here, m is equal to 3. So now I know that lines A and B, let's just call them A and B. I don't really care how you refer to them. Lines A and B are parallel. So A is parallel to B. Actually, if you have a line, it should be something like AB is parallel to CD or something like that. But you can just say the first line is parallel to the second line because slope is the same. I also know on the third one, m equals 0. That slope is not the same, and it's not the inverse reciprocal. What's the inverse reciprocal of 3? The inverse reciprocal of 3 is negative 1/3, because the reciprocal of 3 is 1/3. 3 over 1 switches to 1 over 3, and we have to do the inverse, so it's negative 1/3. There is no line here where the slope is negative 1/3, so there are no lines that are parallel. That's going to be your explanation. I don't have it all written out like that, but what I'm looking for an answer here is something like the first line and the second are parallel because their slope is the same. Their slope is 3 in both instances. The third line is neither parallel nor perpendicular to any other line in there because the slopes are neither the same nor are they inverse. I want to say proportion again also, the inverse reciprocals. So your assignment, you know what, I'm not going to say what the assignment is because I may want to change it and still use the same video. So I just want you to check the website for the assignment, and if you have any questions, just ask in class. Thank you.